This section is a general review of whole numbers and decimals. Be sure you have your notes in front of you that you can print. So let's start with answering a few fill in the blanks here, just about some definitions. It says the answer to an addition problem is called the sum, S-U-M. The answer to a subtraction problem is called the difference. The answer to a multiplication problem is called the product. And an answer to a division problem is called the quotient. Just be familiar with that terminology. And same thing with these properties that we're getting ready to go over. It's not that you need to memorize them, but you do need to know how they work and be familiar with their name. So the first property we're going to talk about is the commutative property, and there are two of them. There is the commutative property of addition and the commutative property of multiplication. They work the same way, but obviously one is adding and one is multiplying. So let's look at that commutative property. What it says is that for addition, if you are adding two things, it doesn't matter what order you add them in. So if, for example, 3 plus 4 is the same thing as 4 plus 3. For multiplication, it again is about the order and saying that it doesn't matter the order that you multiply in. So if you're multiplying A times B, it's the same thing as B times A. So 3 times 4 is 12. It's the same thing as 4 times 3. You know those intuitively. It's just that you may not be familiar with the name of the property. The associative property is our next one. Also has two pieces, the addition and subtraction, addition and multiplication parts of the associative property, where the commutative property was about order and the order that you do things in. The associative property is about how you group things, group numbers, if you are adding or multiplying more than 2. So for example, if I am adding A plus B plus C, what this property says, as long as I keep the order the same, I can either add the first two and then the third one, or I could add the second and third one and then the first one. So for example, if I have 2 plus 3 plus 4, now on the other side, I'm going to write that the same way, same order, but on the left side, I'm going to add the 2 and the 3 first to get 5. 5 plus 4 is 9. On the right-hand side, I'm going to add the 3 and the 4 first. 3 plus 4 is 7. 7 plus 2 is 9. I still get 9 in either case, but it comes up a different way because of the order that you are doing it in. Multiplication, same thing. If I am multiplying 3 numbers together and I keep their order the same, it doesn't matter if I multiply the first 2 and then multiply that times the third, or if I multiply the second and the third and then multiply that times the first. So let's do the same numbers. 2 times 3 times 4, 2 times 3 times 4. I can either say 2 times 3 is 6 and 6 times 4 is 24. Or I can say 3 times 4 is 12, do that first, and 12 times 2 is 24. So I still get 24. So just remember that the commutative property is about order and the associative property is about grouping, how you group numbers together. All right, let's look at, oh, by the way, before we look at the zero properties, you need to realize that the commutative property and the associative properties do not apply for subtraction or division. For example, commutative subtraction, 7 times or take away 4 is not the same thing as 4 take away 7. They are related, but they're not the same. And same thing for the associative properties. All right, looking at the zero properties, we have 4 of them. The zero property for addition says if you start with a number and you add 0 to it, you just get back that number, and you know that again intuitively. So 4 plus 0 is just 4. For subtraction, this one does have subtraction. If I start with a number and I take nothing away, obviously I get what I started with. So 4 minus 0 is 4. Multiplication says if you multiply by 0, you always end up with 0. So 4 times 0 is equal to 0. Division, there are actually 2 of them, and this one is real easy to get confused, so you want to be careful with this. If you have 0 divided by a number, you can do that. That is equal to 0. Notice what it spells if you read it vertically. It spells on. So you're on, there's an answer. You're on for an answer. But if you have some number divided by 0, that is undefined. You cannot do that. Notice what it spells. It says no. You can't do it. So if I have 0 divided by 4, that is 0. But if I have 4 divided by 0, that is undefined. And I kind of ran off the page there. I'll scoot it over so you can see it. There are also properties of 1. We have the multiplication property, which says if you take a number and you multiply it by 1, you get that number back. So 4 times 1 is 4. I think you, again, know that intuitively. And division, there are 2 of those. If you take a number and you divide by 1, you get the number. But also, if you take a number and you divide by itself, anything over itself, you get 1. That's where the 1 comes in. So 4 divided by 1 is 4, but 4 divided by 4 is 1. So you just want to be familiar again with those general properties. All right, we're going to go over quickly some basic whole number and then some basic decimal properties and operations. So let's start with addition. If I wanted to add these two numbers, the thing you want to do first is start with the larger one. We're going to write them vertically, 1, 2, 4, 9, 3, 1. Not necessary to put in the commas when you're actually lining up your numbers. And then underneath that, we're going to write 46,278. You just have to be very careful that you line up the places and keep your columns straight. And then all you do is add. 1 and 8 is 9, 3 and 7 is 10. We carry a 1. 1 and 9 is 10 and 2 is 12, carry the 1. 1 and 4 is 5 and 6 is 11, carry the 1. 1 and 2 is 3 and 4 is 7, nothing to carry. Bring down the 1, now count over 3 and put in your comma. So nothing too complicated there, just a quick review. If you have more than 2 numbers to add, I usually write them from greatest to least in vertical order. So I'm going to write 1647 and then 246. I'm going to write 85 next, although it doesn't really matter, but I just like to keep them in order. And then you just add down the column. 7 and 6 is 13 and 5 is 18, 19, 20. Put down the 0, carry the 2. 2 and 4 is 6 and 4 is 10, and 8 is 18, and 3 is 21, carry the 2. 2 and 6 is 8 and 2 is 10, carry the 1, and you end up with 2010. And by the way, if it's just a 4-digit number, you don't have to use a comma. After 4 digits, you do. The one I want to focus on, though, is this one on decimals. When you add up decimals, you do not line up digits. Instead, you line up decimal points. So I see that 2.06 has a decimal point, but 45 does not. So you have to assume that the 45 has one at the end. And then the 2 goes under the 5 so that the decimal points line up. I write 06, which means I have to fill in with zeros on the 45. And then you just add. It's like it was money. $45 plus $2.06. So don't line up digits, line up decimal points. And then you just add as you normally would. So 47 and 600ths, or 47.06. All right, let's look at the next page. And we're going to look at some subtraction. And believe it or not, of all the 4 operations, add, subtract, multiply, and divide, probably subtraction that causes the most problem. I know it is for me. If I'm talking or I'm in a hurry and I'm subtracting, that's where I'm more likely to make an error. So this says subtract 29 from 543, which means you start with the 543, you subtract the 29 from it. Because they are not decimals, I line up the digits. Now, I can't take 9 from 13. This is what messes people up. So you have to go to the 4. You're borrowing a 10, so that's a 10, and a 3 makes a 13. 13 take away 9 is 4, 3 take away 2 is 1, and then 5 take away nothing. You check subtraction by adding back, and I just do it upside down. 4 and 9 is 13, carry a 1. 1 and 1 is 2, and 2 is 4, and 5 is 5. 5 and 0. I want to show you a little trick with this next one. Subtract 174 from 900. I don't know how you were taught, but I was taught, well, if you go next door and there's nobody there, then you got to go over to the next one. And if this had been 90,000, you would have had to keep going, and it becomes very confusing. So I'm going to show you a different way. First off, don't do what second graders do and subtract upside down just because you want to take the little number from the big one. It's always going down. 0 can't take away 4. So here's what we're going to do. We're going to borrow a 10, but not from that 0, but from everything that's left. So we're borrowing it from 90. So 1 below that is 89. So I'm going to make that an 89. This now becomes a 10. 10 take away 4 is 6. This is a 9. 9 take away 7 is 2. This is an 8. 8 take away 1 is 7. And I was able to do that in one step, rather than borrowing and making that a 10 and then borrowing it again and making it a 9. That's very, very confusing. So let me show you one more time what you would do. Let's make that instead 9,000. Take away 174. All right? So we're going to borrow, but we're going to borrow from everything that's left. So you're borrowing from the 900. 1 below that is 899. And then this becomes a 10. Don't forget that becomes a 10, not a 9. 10 take away 4 is 6. 9 take away 7 is 2. 9 take away 1 is 8. And 8 take away nothing is 8. So you can do that no matter how many zeros you have. So it's a very handy little device there to use, a little method. Here we are subtracting decimals. So again, we do not line up the digits. You line up the decimal points. 85 doesn't have a decimal, so we're going to write 85 and then put that decimal in. How many zeros do I add? You add 2 because that number has 2. So it's going to be 85.00. Take away 17.31. Now when you subtract, just like you did when you add, you just bring the decimal point down and then you subtract as usual. So we're going to use that little 0 thing that I just showed you, where I'm going to make this a 10 and I'm going to subtract from 850, which is 849. You just go down 1. And now let's see what we have. 10 take away 1 is 9. 9 take away 3 is 6. 4 can't take away 7, so I still have to borrow again, but it's easier than if you had to borrow across zeros. 14 take away 7 is 7, and 7 take away 1 is 6, and you end up with 67.69. You probably are going to want to practice subtraction, again, especially with decimals, just because it's where people make most of their mistakes. All right. Let's now move to multiplication. We will do one with whole numbers and one with decimals. So with whole numbers, 631 times 125, you were just going to multiply one digit at a time. So 5 times 1 is 5, 5 times 3 is 15, carry a 1, 5 6s are 30, and 1 is 31. So we use the 5, we're now ready to use the 2, placeholder 0, and now use the 2. 2 times 1 is 2, 2 3s are 6, 2 6s are 12. We're through with the 2. I'm going to put 2 placeholders, so I'm underneath that 1 that I'm going to use. 1 times 1 is 1, 1 times 3 is 3, and 1 times 6 is 6. Now you got to be careful here, because if you write very small or crooked, you'll get your columns all messed up. So what I'm doing right now is just adding. 1 and 6 is 7, and 1 is 8. 3 and 2 is 5, and 3 is 8. 7, whoops, that's a 7. Put in my comma, and you get 78,875. All right, let's look at the next one. 23.6 times 0.78. First off, we're not going to use that leading 0 in the front. It's just something that we did in Florida when FCAT came out. Now, if there was a 0 after the decimal, you have to include it, but in front of it, you can just leave it off. So what you're going to do to multiply here is you're going to line up your digits, not your decimal. You line up the decimal points and add and subtract, but with multiplication, you line up the digits. So it's 7, 8, the decimal point goes here. Now we're going to multiply as if there were no decimals, and then at the end, we will put the decimals in. So we have 6 and, multiply. 8 times 6 is 48, carry a 4. 8 3s are 24, and 4 is 28, carry a 2. 8 2s are 16, 17, 18. Again, placeholder. 7 6s are 42, carry a 4 again, so I'm just going to keep that one there. 7 3s are 21, and 4 is 25, carry a 2 again, that was lucky. 7 2s are 14, 15, 16. So this so far is just like whole number multiplication. So I add 10, carry a 1, 14, carry a 1, 8, and 1. Now we have to place the decimal point. So what we do is we count how many decimal places we have in each of our 2 multipliers. So here I have 1, past the decimal. Here I have 2. I add those up, and in my number I have to have 3. So I count over 1, 2, 3, place my decimal point. All right, let's look at some division. Notice it says find each quotient, so that means division. And I've shown 3 different ways you can indicate division. Typically in algebra, you don't use this symbol, and we certainly don't use this symbol. We use fractions to indicate division most of the time. But let's take a look here. 42 divided by 42, we know anything divided by itself is just 1. 64 divided by 8. And here it's 3 into 21, and we know that goes 7 times. So you need to be able to do it with any of those indicators of division. Let's look at a long division. I know nobody likes this, including me, but we have to be able to do it. So it is going to come up a couple times in the algebra class. So let's go through a real simple one first. We're dividing 3 into 2,541. 3 won't go into 2, so we move over. 3 into 25 goes 8 times. The 8 has to be above the 5. 8 3s are 24. Subtract. Bring down 1 digit. 3 into 14. It won't go 5 because that would be 15, so it only goes 4. 4 3s are 12. Subtract. Bring down the next digit. Divide again. 3 into 21 goes 7 times, and it actually comes out evenly on this one. You can check by taking your answer, which is your quotient, multiplying it by your divisor, and when you do, and I'm not going to go through it, but when you do, you will see that you get what's underneath, which is called the dividend. All right, let's do another one. Divide 3705 by 5. So it's 5 into 3705. You already know it's going to go evenly because 5 always goes evenly into anything ending in 5 or 0. 5 won't go into 3, so we say 5 into 37 goes 7 times. That makes 35. Subtract, bring down 1 digit. 5 into 20 goes 4. That's 20. Subtract, bring down one digit. 5 into 5 goes 1, and it goes evenly. Again, you can check it. I'm going to let you do that on your own with multiplication. It does check. All right, let's look at the next page. With this is more division, and it's getting a little bit uglier. So here we want to say divide 1358 divided by 23. So 23 into 1358. And by the way, if you are one of those people, and there are many, you're not the only one, who does not know your multiplication facts at this point, this is going to be a difficult class, and so will every class that comes after. So it's time to go to the dollar store and get yourself some flashcards and learn the multiplication facts. You can't multiply, you cannot divide. All right, this time, since we have a double-digit divisor, we say 23. Will it go into 13? No, so I move over. Will it go into 135? Yes, but how many times? Well, I'm going to say how many times would 20, because that's close to 20, go into 135? 5 or 6 times. You can try either one. I'm going to try 5. 5 times 3 is 15, carry 1. 5 times 2 is 10, and 1 is 11. Now, when I subtract, as long as what I get is smaller than my divisor, then I did it correctly. So it is correct. It wasn't 6. If you had done 6, your number would have been too big. So we subtracted. We now bring down the next digit and we divide again. How many times does 23 go into 208? You may not be able to guess this very easily, but it went into 135 5 times. 208 is a lot more than 135, so it's going to go in a lot more times. It happens to go in 9, but you might have to experiment with 8 and then find out, oh, that's not big enough. It may take some experimenting. 9 threes are 27, carry 2. 9 times 2 is 18, 19, 20. That is not bigger than this, so it's okay. And I have a remainder of 1. And for now, we're going to leave it like that. The answer is 59, remainder 1. All right, let's do a little bit harder one, because we are now going to divide by a 3-digit number. So I am dividing 403, which is close to 400, so that should be helpful, into 51,600. Well, it won't go into 5, it won't go into 51, but it will go into 516. And it's pretty easy to see that 403 is close to 400. So I think, how many times would 400 go into 500? 1 time. The 1 goes above the 6. So that's 403. Subtract. This is not bigger than that, so we're still good. Bring down one of the zeros and divide again. Again, I'm going to say, how many times would 400 go into about 1100? Well, it won't go 3 times because that would be 1200, so I'm going to try a 2. 2 threes are 6, 2 zeros are 0, 2 fours are 8. Remember, when I subtract, it has to be smaller than 403. Here I need to borrow 10, take away 6 is 4. I have a 2 here, and I have 11, take away 8 is 3. So I have 324, which is smaller than 403, so we're good. One more to bring down, and I am looking at this as 400 going into 3200. That would go 8 times. 8 threes are 24, carry a 2. 8 zeros are 0 and 2 is 2. 8 fours are 32. Subtract, I have to borrow, and I have 3 take away 2, so I end up with a remainder of 16, or 128, remainder 16. I kind of got all pushed together. All right, the next one that we have here is an example of dividing by a decimal. So, or dividing into a decimal, one or the other. So it says divide 5.98 divided by 115. So you're dividing by the bigger number here. So 115 divided into 5.98. All right, the first rule of dividing decimals. If the number that you are dividing by, 115, your divisor, is not a decimal, but the other number inside, the dividend, is, you just bring your decimal point straight up before you start. And then you just divide as usual. So we say, will 115 go into 5? No. I'm actually going to put a 0 up there. Will it go into 59? No. So I have to put that 0. This 0 was optional. This one is required because it comes after the decimal point. How many times will it go into 598? Well, 598 is close to 600. So I'm thinking it might be 6 times, but in my mind, I can see that if I say, when I multiply back as 6, this is going to be 6 times 1 is 6. It's going to be too big. So I'm going to try 5. 5 times 5 is 25, carry 2. 5 ones are 5, 6, 7. That's a 7. 5 times 1 is 5. So that was the right choice. I subtract. Now, because this is a decimal, I can't write remainder 23. So what do we do when it doesn't come out evenly? You add a 0 to the end of the decimal, that does not change its value, and you bring it down, and then you divide again until it either comes out evenly or the directions tell you to round off to a certain place. So I'm going to divide 115 into 230. It happens to go twice, and it goes exactly twice. So we end up with 0.052. And as I said, the first 0 was optional, but this 0 has to be there. It's a place value holder. All right, looking at the next page, we're going to look at some rounding, and then we will do a division problem where we have to round and we are dividing by a decimal. So in general, real quick review of rounding rules. You locate the digit in the given place. So the directions are going to say round to the nearest 10 or round to the nearest hundredth. Underline it. Locate the digit to its right. If the digit is 5 or greater, you round up. If it is less than 5, you replace that with a 0, and you keep the other numbers as they are. And I'm going to show you how you do that on this problem. So it says divide 17.5 by 0.48. So we divide by 0.48 into 17.5. Now this is different than the last one because we are dividing by a decimal. So what you have to do when you divide by a decimal is you have to move the decimal point to the end of the number. So that required me to move it 2 places. In order to then divide and have it turn out the same, I have to also move this one the same number of places. So 1, 2, now bring it up, and you fill in the hole created with a 0. And now you just divide as you always divide. So will 48 go into 17? No. So we move over to 175. It will go 3 times. Notice where the 3 went above the 5. 3 8s are 24. 3 4s are 12. 13, 14 because I had to carry 2. Subtract. 31 is smaller than 48, so we're good. Bring down my 0 and divide again. 48, which is about 50, close to 50, that's how I'm thinking of it, into about 300, goes 6 times. 6 8s are 48, 6 4s are 24, and 4 is 28. Subtract. Now, be careful here. This is where subtraction errors are often made. I'm going to borrow here, make that a 10. 10 take away 8 is 2, but 0 can't take away 8. So I go over here, I make that a 2, and then I end up with 10 take away 8 is 2, 2 take away 2 is 0. So that's one of those subtraction places where it's easy to make a mistake. Now, what do? It didn't come out evenly. I have my decimal point placed, so I'm going to go ahead and add another 0. My directions say to round to the nearest tenth. Well, I don't even have anything in the tenths place yet, so I have to keep going. So we're going to bring that 0 down, divide again. About 50 into about 200 goes 4 times. 4 times 8 is 32, 4 times 4 is 16, and 3 is 19. We're going to subtract again. That's an 8, I have to borrow. 10 take away 9 is 1. And I have a mistake here. This should have been a 2, sorry. Now let's check it. 8 and 2 is 10. 1 and 2 is 3, and 9 is 12. So yeah, I made a mistake there. That was a 1. So it was 11 take away 9. Sorry about that. See what I mean? It's very easy to make subtraction errors. Now, we can't stop even though we have a digit in the tenths place because it says to round to the nearest tenth. And my directions up here say I have to look at the digit to the right of the given place. So I have to go one more place. So I'm going to add another 0. Bring it down and divide again. It's about 50 into 280. That goes 5 times. 5 8s are 40. 5 4s are 20, and 4 makes 24. Subtract. This is not bigger than that, so I was correct. Now I can stop, but I have to round this off. So I'm rounding to tenths place. That's my 4. I look at this number. This number tells me what to do. It's 5 or greater, so I bump that up. So it rounds off to, that means approximately equal to, 36.5. 36.5.